Hello, student. Welcome to second slide of the lecture. In these slides, we'll talk about the core four principles of object-oriented programming. Since you have learned Java, and Java is an object-oriented programming, and in this course also, what we are going to implement any data structures, we are going to use Java. And before jumping to implementing any data structures, we must have knowledge in Java properly. So I believe that you already have basic knowledge of Java, but you didn't learn some advanced, concept of Java language. Java is an object-oriented programming, and in this lecture, we'll talk about, you know, mm, four principles, which are, you can say, four pillars of any object-oriented programming language. So what are the four principles? It's called abstractions, inheritance, polymorphism, and encapsulations. We'll talk about each of them and we'll see different examples, and we'll try to compare this concept with the real life examples. Let's start with the abstractions. In the previous slides, we have seen examples using television. Here also we are giving the same examples. So the abstractions is basically saying that what is the mathematical model of any objects, of any data structures, or of any components. Here are televisions. In the previous examples, previous slides, we have seen, we were talking about that. We only know how to use these televisions, but we don't know any implementations inside of the televisions. That was basically an example of abstract data type. An abstract data type is a part of abstractions. Is basically saying the same thing, that televisions are anything that we know how to use them, but we don't know what is the implementation inside of that. Then it's basically said that abstractions. Here we can turn on and off, we can receive signals, we can adjust audio video, but we don't know any implementation inside of that. That basically saying that a real it represent a complex systems to a real complex real world in a simplest manner. So probably inside this television, it's very complicated. It's if you want to learn how to implement a television, how to build a television, how to write any operations, build any operation to turn on off or to receive signals, probably it would be more complicated. But using of that television is not that much complicated. So presenting a complex real world into a simplest manner is kind of an abstractions that basically tells you this is the model, this is the logical model of these objects. So you don't know any implementations, you just know how to use them. So this is the one pillar of the object-oriented programming. So you will see a lot of examples in object-oriented programming language, such as in Java. For examples, uh, uh, we we'll see those examples in these lectures. The next principles is called inheritance. So inheritance basically says that if you compare with the real life, say a son inherits characteristics from his father. Probably a son has similar characteristics of his fathers. So that means it inherits a son adopts, you know, uh, characteristic from his father. That calls inheritance. Similarly, in our Java programs or in our computer programs, we have several inheritance process. So we have one class and we can have some other class, and second class can inherit several characteristics of the previous class. So we'll see those examples. So here we are talking about that is a is class can be a subclass, or a class can be an inner class of other class, and in that case that subclass or inner class can, you know, can be can adopt some inheritance, can adopt some characteristics from the parent class or previous class. We'll see those things. So this is the second principle of object-oriented programming. So polymorphism is third principles of object-oriented programming. So here in the picture, you are saying that there are two brothers. They are looks alike, but they are two different human beings. So in polymorphism, also in polymer, so this is the real world examples. So we can have two different human being, or you can have two different components, two different objects. Those looks alike, but they are two different things. So similarly in Java program also you can have some methods, or you can have some other components. Those basically looks alike, but they are two different things. So we'll see some examples how polymorphism concepts are implemented in Java language. We'll see those things. Last one is encapsulations. Encapsulation is saying that trying to hide internal details of an object from outside of real world. So we already have discussed that a television has a lot of complex functionalities inside them, but we don't know those things. We just know how to use those things. The idea, the way it hide its complex world from the outside of world, it's called encapsulations. So that don't be confused with encapsulation and abstractions. These are the two different things. We'll talk about the difference between encapsulation and abstractions. The encapsulation saying that hiding internal complexity, hiding internal information from outside world, and abstraction saying that the presenting mathematical logical model of something. Okay, there are two different things. One is hiding, another hiding complex thing, another one is presenting mathematical or logical model or abstract view of an object. So these are the two things. So these are the examples. So for examples, we have a mobile. Say in the mobile, so the front view, you can see that the touch screen, and other things of the mobile are the abstraction. This is the simplest manner. The simplest way to representing to us that we can use mobile. And the encapsulation is the concept that basically hiding all the internal complexity uh, inside the mobile. So we don't know what are those things, and they are hidden from us. So in this slide you can see that this is a some simplest view that calls abstractions. So we can use this simplest view to access this mobile, and then encapsulation hiding all the internal structures, internal complexities from the outside the world. So these are the two different things, encapsulation and abstractions. So let's talk about each of them in details. So let's start with the encapsulations. What is encapsulations? The internal representations of an object is generally hidden from view outside of the object definitions. Typically, only the object's own methods can directly inspect or manipulate its field. So, what I have seen that encapsulations hide all the internal complexity from outside the world, and from outside we might have some methods, or we might have some abstract view, or like in mobile examples we have some outside world you know functionalities that we can use to manipulate internal structures and manipulate any internal fields to do some operations. So here, so we have seen, so the televisions hide all the internal complexity inside that, and we have some outside method that goes turn on off, receive signal, audio, video. We use this method to manipulate all the internal things. So we don't see internal complexity, we don't feel any internal complexity, so those are hidden, but we can manipulate those internal things using some functions, some method which is outside of the components. Similar to the televisions, we use turn on and off button, we use receive signal button, we have adjusting audio video button to manipulate all the fields inside the televisions. So if we compare, now if we consider the encapsulation concept in Java programs. So in Java we have a class, and inside class we can have some public variables, we can have public method, and we can have some private method also, we can have some private variable also. So the private method and private variable cannot be accessed, cannot be seen by anyone from outside of the class. So that means these private information are hidden from the outside of the world. So these are the complexity of this class. So nobody can see these hidden informations, but they can manipulate these private informations using some public variables and public method. So these are the similar to the turn on and turn off button of the television, these public methods. So outside of our world, so like us, we can use public variable and public method to manipulate any private variables and methods, similar to the televisions. So in Java, this is the concept of encapsulations. In Java we can have class, and class have public variable and method, and they can have private variable and method, and private variable and method are hidden, and public variable and method are visible to the outside world, so those can be used to manipulate private informations. So this is the idea of encapsulations. So why we need encapsulations? Because we need encapsulations for information hiding also. Obviously we don't want to show a lot of information to the users or to the outside worlds, and restrict access of confidential data from outside. So we don't want to allow anybody to access any confidential data. Those are hidden to the inside some class or inside some objects. So these are the two basic motivations for having encapsulations in Java. So this is one example. Say for example, say we have a class called account, and in that account class we have two variables, account numbers and account balance, and those two are private, so nobody can access, nobody can see these two variables from outside of this class. And it has one public method, it called deposit. So public method can be visible to outside of the world, so anybody can access this method. However, a, a user or a other class can manipulate any private variables using this public method. So if you see that inside the public method, uh, they have account balance variables which can be updated, which can be modified, but these variable is private variables, and you can see that anybody can call deposit method and can change account balance, but nobody can, you know, can change account balance directly without accessing deposit. So if we have, access, if we have access to the private informations, then hacker can change the account balance, directly. So that's why this is the idea that we don't want anybody to allow access our confidential information directly. That's why we keep them in a privately, and we can, we create some public things so anybody can access, manipulate those private informations through some public method, so that means we can have some control on confidential informations. So the here, if we don't have any controls, then probably hacker can change our account balance directly. So this is the idea. So if we have public method to access any private information, then probably you can call that deposit public method to change that any account balance. So this one is the idea of the encapsulations. Now we talk about the abstractions. So before going to the abstractions, we talk about abstract data type. We already have discussed what is abstract data type. Abstract data type is something that present complex real world in a simplest manner. So a object can have a lot of internal complexity. So but we don't have those idea. We just handle the mathematical and logical models, or we have some simplest presentations that can be used, functionality that can be used to manipulate the internal complexity. That basically says that abstract data type. So the encapsulated data together with its method is called abstract data type. So here we have seen that a abstract data type probably can have some encapsulated data, and it can have some method also. Those can be those can be private also. So if the data fields are private, they can be accessed through public method that we have seen in our account deposit examples. So this idea is saying that we will have some, you know abstract view of the complex things. So interface is one implementation, one I know, one idea of abstract data type is a kind of a abstract data type applications. So interface, we'll see one examples how to write interface. Interface basically saying that what are the methods are used in, and their descriptions, some arguments, return results, but an interface never tell about the implementations or any algorithms. So you will create an interface which is an abstract data type that basically is saying some logical model of the data structures. For example, it will tell about the data member, it will tell about the method, but it will never tell about the implementations. Let's see one interface examples. Interface is in data structures. Let's go to the interface. Say, so we create an interface using interface keyword, and ATM is an interface name. So ATM, we know that a bank can have, ATM booth, ATM process. So several banks can have same ATM process, but they have different functionality. They have different conditions. Probably they have different implementations, but in general, all banks have the similar ATM process, same ATM process. So if you want to define a ATM interface, so that ATM interface talk about the logical view of the ATM process. Since it doesn't talk about the implementation, so any bank can use that ATM process to implement in their own style. So it basically give you the blueprint of the ATM process. So for examples, so we can have three different functions, three different methods in the ATM process. The first method is called verify pin. So verify pin basically takes a pin and verify that whether the pin is correct or pin is valid. So this is one method. Then then second method is select account method. The select account might have several account type: saving account, checking account. So they can have different type of account. So we can have a method to select one account, that is called select account method. And finally it have method called withdraw. That withdraw method takes an account that was selected using select account method, then amount that you want to withdraw. So if it withdraw properly, then it returns boolean true, otherwise it returns false. So if ATM interface probably might have several methods, but we are discussing only three basic methods. So to you giving you idea that what is interface or what is abstract data type. So we know that interface is an applications is kind of an abstract data type. So we know that abstract data type gives you only models. It doesn't tell you the implementation. Here we can see that they are talking about the three different methods, but they didn't talk about the how to implement those things. So there is no any definition of each method. So this is the idea. Whenever you want to build some abstract data type, so interface is one kind of abstract data type. You can build, you can define any abstract database in that way, so you will not have any implementation of any of the method in the abstract data type. Let's go to the slide again. So whenever you have the interface, so we have, if you have built some interface like ATM, then you can implement those ATM interface to any class. So probably you create a ATM Bank America ATM for all banks. These are the two different class. So it implements ATM. So that means you use all three method that we have seen in the ATM interface, and we can write definition of those three information in a style that Bank of America need. And you can create another class for ATM for all banks, all other banks. Then you can implement the same methods from ATM interface in other styles that probably other bank needs. So we can create interface, then we can implement those interface in different class. Now we talk about the inheritance, the third one. So we have seen that inheritance is a way to reuse code of existing object or to establish a subtype from an existing object. So that means you have a class. Now you are creating another class. That second class adopts all the characteristics from the first class. That means you don't need to write a method, those are defined in the first class. You don't need to write those methods in the second class. So you can reuse those methods from the first class. So this is the idea. So for examples, in the real life inheritance examples, a person can be a student, a person can be employee, and a student can be IT student, a student can be math student. Similarly, an employee can be driver or employee can be engineer. So these are the inheritance concept. So one under another. So if you consider person is a superclass, then under this it has two different subclass, student and employee. Student is a person, employee is a person, but student is not an employee. So that means a person is a superclass, and it has two different subclass, student and employee. Both are the person, but both are the different characteristics. So, and student can be a IT student and math student. So IT student is a student and it's also a person. Math student is a student and it's also a person. But student has two different subclass. One is IT student, another is math student. Similarly, employee can be a driver and engineer. So driver is also employee and is a person. Engineer is also employee and is a person. So, so the employee, driver and engineer are two different subclass of employee class. So this one is an example of in Java. So we can have class called mammal, and mammal has four different members, and it has three different methods: eat, sleep, reproduce. So all kind of mammal can can eat, can sleep, and can reproduce. So this is a superclass. But a mammal it can be a wildcats. A mammal can be a pet dogs. So all wildcats and pet dogs have the similar characteristics that we have seen in the mammal, but wildcat might have more functionalities, and which is different than the pet dog. So this is kind of a some examples what we can see in Java programs. So superclass and subclass. So we have seen this one is the superclass, the mammal is a superclass, and wildcats and pet dogs are the subclass. So the definition is the class from which subclass is derived is called superclass, and also called base class or parent class. So subclass is the child class that basically adopt all the characteristics from the superclass. So these are the two different class. Let's see some programming example of inheritance. Say for examples, we have a class called computer. We have a class called computer. A computer has 4 or 5 different members. What is the manufacturer of the computer? What is the processor of the computer? What is the RAM size of the computer? What is the disk size of the computer? Processor speed. Then we have a constructor, and then we have different method: compute power, to compute power of the computer, to find out the RAM size of the computer, to find the processor speed of the computer, to find out disk size of the computers, and finally print those informations. So computer is a class that has several members and the method. Now if you want to create a new class called notebook, notebook is a computer. It has similar kind of informations. It might need similar kind of methods, similar kind of members, but it might need some more informations. For examples, if you go to the notebook class, you can see that public class notebook extends computers. The extends keyword saying that notebooks inherits all the properties from the computers. So in the notebook, you can see that we didn't define all those information. Those are defined in the computer. So we didn't define manufacturer, we didn't define processor, we didn't define RAM size or all other things. But notebook also has those characteristics. Those characteristics are coming from the computer class. So that's why we use extents. So extents is a keyword that says that notebooks inherits properties from computers. So notebook is a concept of inheritance. So on top of all those information that coming from the computers, the notebook also has two additional informations. What is the screen size? What is the weight? So you can see that the screen size and weight are not available in the computer class. So in the notebook class, we have two additional information: screen size and weight. So this is a notebook is a subclass of computers. So it might have more informations, but it add up all the characteristics of computers. So when we call those notebook, we basically can access all those variables. Remember, those are defined in the computer class. You can see that processor, RAM, disk, process speed, screen. So all those information, those are defined in the computer. We can access those things, and in additionally, we can have those additional members in notebooks. Though this is the concept of inheritance, we can create a superclass, and then we can create subclass. Superclass is a computer class and subclass is a notebook class to reuse existing code. So far you have seen in your previous course how to use public, specifier, a modifier, uh, then private, and you know so another one is protected. So protected visibility has some things. So you can declare any data or method with protected visibility that can be accessed in the class defining it. So and in any subclass of that class or in any class in the same package. So any subclass can access any protected data field, and any other class in the same package can access this protected data type. So you can declare any member as protected in that way. Now talk about the easy versus hazard relationships. There are two different relationships, easy and hazard. What is easy? When we talk about the inheritance, it basically create a easy relationships. For example, so when I say that a notebook is a computers, a computer is a class, then we created a subclass called notebook. A notebook adopts all the characteristics of the computers, inherits all the characteristics from the computer. That's why we can say that a notebook is a computers. That inheritance create a is a relationship. So what about the has a relationship? Has a relationship between classes mean that one class has the second class as an attribute. For example, so we can declare any objects of a class inside another class. Then we can say that the second class has some properties of the first class. It's not something that the second class is a first class. So that means we can create of object of the first class inside the second class. That basically says that the second class has some characteristics of the some class. So this kind of idea basically create has a relationships. So for examples, this one is the is and has a relationship diagram. For examples, you have a bike class, and you have a some other class of bike, uh, uh, pulsar. So the pulsar is a subclass of a bike class. So you can say that the pulsar is a is a bike. So when you have another class called engine, that you can create that object in the pulsar of the engine class. In that case, you can say that pulsar has a engine. You cannot say that pulsar is a engine. So that basically create a has a relationship. So this is the end of the second slide. So this is your activities. You should read this, these chapters of the textbooks. The textbook that was given in the syllabus. You have to read those things to learn more about those things. Thank you, and we'll go for the third slide now.